All right, Algebra 1, we have a couple things to cover today. The first thing is kind of the special solution, so empty sets and all real numbers are the two types of special solutions. Okay, so kind of like when we have infinity or no solution, it's kind of the same thing. So sometimes when you work out an inequality, just like we've been doing, you might get some kind of special solution because the variable cancels out. So like in this one, we're still solving the same way. So I got to distribute the negative 5. I get 9t minus 5t. Negative 5 times negative 5 is positive 25. And then I have less than or equal to on the other side. 4 times t is 4t. 4 times negative 3 is negative 12. Okay, so just like yesterday and the day before, we want to go ahead and combine like terms if possible. So I get 4t plus 25 less than or equal to 4t minus 12. And so when I get t on the same side, they end up canceling out. So what I have left is 25 and negative 12. Well, look at the statement. You got to decide, is it true or false? Okay. If it's true, you're going to say all real numbers. So let's back up here. Something you want to probably write down here is if it's true, your answer is infinity. Okay, or all real numbers. Okay, either one. And then if it's false, if the statement is false, your answer is no solution. Or the empty set is another way to say that. Okay. So that's something you'll probably want to write down. Okay, so I'm going to highlight that just to kind of remind you that's something you'll have to make sure to know. Okay, so back to our problem. This says 25 is less than or equal to negative 12. Well, 25 is bigger than negative 12. So since that is false, my answer is no solution, and I'm done. Okay, so let's go through this second one here. We've got number 2. So distribute. 3 times 4 is 12m. 3 times 6 is 18. And then less than or equal to, 42 is unaffected. But I need to distribute the 6. So I get 12m. 6 times negative 4 is negative 24. And now we go ahead and solve both sides. So again, this side stays the same. Nothing's changing there. This side I have 42 minus 24. So I've got 12m unaffected. And then we've got 42 minus 24, which is 18. Okay, so now when I get 12m on the same side, those cancel, and I get 18 is less than or equal to 18. Well, think about that. Is 18 less than or equal to 18? Well, since it's or equal to, that would be true. So, infinity. Now, let's say an example, a separate example. Let's say our answer was 18 is less than 18. In that case, that would be false because 18 is not less than 18. That 18 is equal to 18. So in that case, it would be no solution. Okay? So I want you to go ahead and try these two. So go ahead and write those two down. Okay? You can pause the video real quick if you need to write those down. So go ahead and try those on your own, either right now or after we're done. So the next section, we're writing inequalities. Okay. So when we have inequalities, verbal statements can be translated. So this is something we've kind of done with equations. Verbal statements can be translated to algebraic inequalities, much like deciphering a secret message or translating from one language to another. Okay, so there's certain words that mean some of these things. So this first one is less than. Okay, is less than. Is greater than. What's another one? There's not a whole lot of extra ones here, but is fewer than would be another one. Or is more than. Those are a couple. So when there's an underline, there's quite a few actually for those. So is greater than or equal to. Is less than or equal to. So along with that comes a few pretty common ones, which one of them being at least. Oops, at most. For this one, at most means it's got to be that or less than. And then this one would be at least. So it's got to be that much or more. Okay, at most, at least. And then if there's a maximum, it's got to be less than that number or equal to it. Or minimum. Okay, so those are some key words that you'll want to keep in mind when you're trying to translate these into algebraic expressions or inequalities. Okay, so we're just going to go through a few of these and then give you a few examples to do on your own. So first one says a number is at most 15. So a number, again we say x or a or whatever, is at most, that's going to be my inequality, 15. So x at most, we said, was less than or equal to. So less than or equal to 15. That's it. So let's do another one here. Number 3, the quotient of a number and negative 2. So quotient, remember, means division. So a number is x and negative 2. So x divided by negative 2 is greater than or equal to, so that one should be easy, 10. And there we are. So let's look at another one here. So this one, 5, the difference between a number and 13. So the difference means subtraction between a number and 15. So x minus 13, not 15, is at least. At least means greater than or equal to 1. Okay, so you got to go kind of one thing at a time there. All right, so same thing here. 3 times a number, so 3 times x, is more than, so greater than, negative 7. Okay, and then let's look at this one here. Negative 6 plus a number, so negative 6 plus x is less than or equal to, so less than or equal to should be obvious, 15. Okay. So let's go to the back, the last few here, and then I'll give you a couple to try. So these are ones we want to solve. Okay, so let's look at number 11, one more, and then give you one to try on your own. So in this case, it says 1/2 of a number less 6. So less 6, that's kind of a weird one. I'm going to skip that one actually and go to a different one. Let's go to number 12. So 3 times a number, so 3x, increased by 7, so plus 7, is less than 11, so less than 11. So it said to solve, so now we got to go ahead and get the x by itself. So I've got 3x less than 4, okay, and then divide by 3, we get x less than 4/3, okay. Now on a graph, that would be kind of like less than 1.3. So if I've got 0, 1, 2, -1, -2, 1.3 would be about right here. And it's an open circle going to the left. Okay. So let's do one more. I'll give you one to try on your own, and then we'll be done for this example. So the difference of 2 and a number is at least -1. So the difference means subtract 2 and a number. So 2 minus x is at least, so that's greater than or equal to -1. So we need to go ahead and get the x by itself. So subtract 2, get -x greater than or equal to -3, divide by -1, and remember from last lesson, if I have -1, I got to go ahead and flip it. X is now less than or equal to +3. So that's my solution. So when I graph that, I've got 3, 4, 5, 3, 2, 1. That is a closed circle, and that's going to the left, less than or equal to. Okay? So go ahead and, along with those other two examples, try number 15 here. So you're going to write it, solve it, and then graph it. Twice a number less than 20. Twice a number less than 20. Okay, so remember, this is a turnaround phrase. So I'll give you a hint there. So less than, in this case, is a minus sign, but it's a turnaround phrase. So you got to say this 20 minus twice a number, and then at most 10. So try and figure that out, and we'll talk about that one tomorrow. Good luck, and let me know if you have questions. Hop on the Zoom if you do. Peace.